Hey everyone, Mr. Fransky here. I'm just going to take you through a few of the examples from the pink graphing packet, the chapter 4.5 graphing. Lots of good opportunities here to use tables. That's how I'm going to do it. If you have a way that works better for you, that's just fine, but I think that this kind of two-table method works well. You'll notice there are two coordinate axes for each one of these problems. I think that the way that this was intended to be done was that you do the reflection and scale on the first one, and then on the second one you include the translation. What I usually do is I do the parent. So instead of reflecting and scaling on the first one, I do the parent function. So let's say it was like sine. So I graph the sine wave on the first one, and then you do your translation of your center line, and you change your period on the second one. That's usually what I do. But whatever you want to do with those is up to you. If you're doing the tables, there's probably not a ton of space. You might have to do that on a separate piece of paper, but it's up to you. Let's take a look. So I'm going to do 2, 4, 6, and 12 here. It's just kind of a nice little representation of the different types of problems. So here we have 4 sine of 2x minus pi over 3 minus 1. So the first thing I want to do with this is clean my x. So I have 4 sine of, so I'm going to pull a 2 out. I have x minus something minus 1. Now that something there I need to multiply by 2 and make pi over 3. So I'm going to put an a there because maybe you don't know what it's going to be. Some people are really good at factoring a 2 out of a fraction. But what I know is that when the 2 factors in here, I need 2a to be equal to pi over 3. So we can just solve by dividing by 2. So a is going to be pi over 3 divided by 2. That's the same as multiplying by 1/2, so that's pi over 6. So I need a pi over 6 where that a is. So I'm going to erase the a and just put a pi over 6 there. The reason I have to do that is because now I see what that shift really is. It's a pi over 6 shift to the right, not a pi over 3 shift to the right. So you just have to be careful with that. So let's see what we have here. Our scale change takes xy, xy to, looks like the x will be divided by 2 because it does the opposite of what you have in here. And the y is going to be multiplied by 4. And the translation takes xy to, let's see, x plus pi over 6, because it's the opposite once again, and then y minus 1. So now we're going to make our tables. So I'm going to start off with just the typical sign. So I have x, and then I have y equals sine x. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine starts at 0, then it goes up to 1, then back to 0, then to negative 1, and then to 0 again. So sine, let's graph the parent up here. So 0, 1, 0, negative 1, 0. That's the typical sine wave. Looks like that. All right. So now let's see what we're going to do with our scale change first. So we're going to divide all our x's by 2. And we're going to multiply all our y's by 4. The y's are always easier. I like to do them first. So we have 0, 4, 0, negative 4, and 0. The x's we divide by 2, so we have 0, then pi over 4, and then we have pi over 2, and then we have 3 pi over 4. Looks like we're adding pi over 4 every time. And at the end we'll have 2 pi over 2, which is just pi. So it looks like our period is now pi. Okay, which we can get also by just doing 2 pi divided by that b value. 2 pi divided by 2 gives us pi. So now we're going to do the with the translation as well. So I got x over 2. We are adding pi over 6 to those values. I have to do a little bit of algebra with those. Then we take our y's here, so we'll have 4y. It looks like we are subtracting 1 from all of those. So let's do the y's first. So we'll have negative 1, then we'll have 3, then negative 1, then negative 5. Shifted down 1 here, so all these are losing 1, and then negative 1 again. Looks like our center line is at negative 1 now. Now for adding pi over 6 to the x's, I might have to do a little bit of algebra around the side. Usually I like to do it underneath, but I don't have any room here. So let's see, 0 plus pi over 6 is just pi over 6. That's not too bad. Now if you think about the circle here, so we started with the values of 0, pi over 4, pi over 2, 3 pi over 4, and pi. So if I'm adding pi over 6 to each one of these, basically we're rotating our circle. So maybe there's a different color to show this, maybe red. So if we add pi over 6, this is now going to be a pi over 6. The pi over 4 plus pi over 6 is going to give us kind of a weird number. It's going to be really close to the top here. This guy's going to be over at 2 pi over 3. This guy's going to be really close to pi over 6 right there, or 6 pi over 6, which is pi. And then that's going to bring us down to right there. So we're basically shifting. We're just rotating by pi over 6 each one of these points, right? So sometimes it's easy to think about that if they're nice values. This one's going to be a little bit weird, so I'm just going to kind of do the algebra. So let's see here. So we have pi over 4 plus pi over 6. So common denominator here, I guess we can go to 12. So this is 3 pi over 12. And this is 2 pi over 12. So added together, that's 5 pi over 12. Okay. Now we have pi over 2. Pi over 2 is 3 pi over 6. Add one more pi over 6, we get 4 pi over 6, which is 2 pi over 3. And we can see that up here, right? If you're at the top and you add pi over 6, that's 1/12 of the circle. That just moves us to the next logical point there. This is another pi over 4. It's going to be a weird one. So let's see here. 3 pi over 4. We're going to have to go to 12s again. So that is 9 pi over 12. Plus pi over 6, which is 2 pi over 12. Looks like it gets us to 11 pi over 12, which makes sense because it's just shy of 12 pi over 12, which would be pi. Now pi plus pi over 6, it's 6 plus 1 more is 7 pi over 6. Getting a little tight to the bottom there, but we got it in. So now we just graph it. So it looks like our center line has moved down a little bit, so I'm going to kind of graph this a little bit lower. So there's -1. We go down to -5. Doesn't have to be perfect, just put it down there somewhere. We go up to 3. So we start at pi over 6. Let's say that's right here. And we start at -1. So let's say it's our pi over 6. I always try to make it so I don't run into the numbers, but it doesn't always work great. Okay, so now at 5 pi over 12, we're up at 3. We'll call this 5 pi over 12. And then at 2 pi over 3, we are back down to -1. Sorry, my line's got a little bit messed up here. Okay, so 2 pi over 3, we're back down to -1. Let's say it's about here. Alright, and then at 11 pi over 12, we're down to -5. Let's say about here. 11 pi over 12, down to -5. And then at 7 pi over 6, we are back up to our center line at -1. Now we just connect the dots. There we go. That's all I'm looking for. All right. 4 sine 2x minus pi over 3 minus 1. There it is. 1 period. That's all I want. All right. Except 2 minus cosine x plus pi over 2. This is number 4. So I'm going to rewrite this as negative cosine. I don't have to clean the x. It's already clean because there's nothing in front of it to pull out. So the period is not going to change. X plus pi over 2. And I'm going to write this as plus 2 at the end. It makes it clearer that we have a vertical shift up of 2 and that we are reflected over the x-axis. So we have a reflection on this one. The first one we've done with a reflection. So typical wave here. So we have x, y equals cosine x. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So cosine starts at 1, then 0, then -1, then 0, then 1. So it starts up, goes down, and comes back up, kind of like a teacup maybe, or the shrug emoji. Okay, and now what we're going to do is we're going to see what our scale and translation are. So it looks like our scale change takes xy to, is there any scale change at all? I don't think so. It's just a -y. So the x is left alone, the y's are made negative. That's what this negative on the front does. And the translation then takes xy to x minus pi over 2, right? Because it's the opposite of what you want. And the y value is plus 2. I'll shift it up 2 with that 2 right there. Okay, so our first is just the x's are left alone, and then we have just negative y values, so it flips them over. So we go -1, 0, 1, 0, -1. So it's going to start at the bottom, go up, and then come back down. It's going to kind of like a bell curve. The x's are left alone. 0 pi over 2, pi, 3 pi over 2, and 2 pi, yep. Now we do our translation. So we're going to have x minus pi over 2. And then we have our negative y's. We are now going to add 2 to all of them. Let's do the y's first. So I have 1, 2, 3, 2, 1. So our center line has been moved up to 2, it looks like, because we moved up 2. That makes sense. X minus pi over 2. So this one's easy to think about with the circle. Period here is still 2 pi. All we've done is we've taken all of them. We're subtracting pi over 2. So 0 is going to go down to -3 pi over 2. Pi over 2 is going to go to 0. Pi is going to go to 3 pi or to pi over 2. They're all just losing pi. We're shifting the circle basically 90 degrees to the right, kind of a clockwise shift. So 0 now becomes -pi over 2. Try to line it up this time better. Pi over 2 becomes 0. Pi becomes pi over 2. And you can kind of see which it's still a difference of pi over 2 every time here. So you can just kind of see we're just going to end at 3 pi over 2. Okay, so let's see if we can graph this. So we need to go left a little bit. We need to go up a little bit. So I'm going to make it kind of like that. Make that line a little bit better, maybe. There we go. Okay, so we start at -pi over 2. Let's say that's right here. Then here's 0. Then pi over 2 will be about here. then pi be about here, and 3 pi over 2 about here. Center line is at 2. And we start at 1, then we go to 2, then we go to 3, then to 2, then back to 1. Okay, make sure you make it look like a cosine wave, right? Don't connect them with straight lines. Lots of people like to do that, right? But it's cosine wave, so it should start by going straight to the right and then kind of have a slope of about 1 going through the axis, and then a 0 slope at the top, and then we end up with a 0 slope back at the bottom. Not too bad. Let's try one that's a little bit more fun. Cosecant. All right, so cosecant, remember, this is 1 over sine. So what we're going to do is we're going to graph the sine wave. We're going to graph the sine wave. And then we're going to put the asymptotes where the zeros are, and then we're going to make it touch at the bumps. Right? I always use dotted line for the sine wave because the sine wave isn't really part of it, but we have to graph it to be able to graph cosecant. So what I'm going to do first is I'm just going to use, first I'm going to clean the x. So we have 4 cosecant 2 times x minus, going to have something in there, minus 1. So whatever's in here, I'm going to multiply by 2, has to make pi over 2. I think that's going to be pi over 4. If you struggle with that, remember you can always use that a value and say 2a equals pi over 2, and then divide by 2 to get the pi over 4. So it looks like our scale change takes xy to x over 2. Remember the opposite for the x, and then 4y. Translation takes xy to x plus pi over 4. And then the y's are all minus 1. Okay, so let's get our typical values first. So x and then y equals cosine x. Okay, so the x value is 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're using sine. Why did I write cosine? Using sine here. Okay, so sine goes 0, 1, 0, negative 1, 0. So we're going to graph the sine wave, and then we're just going to make the bumps touch. Okay. So let's do the scale change first. So we're going to divide all our x's by 2. We've done that before. And then 4y. So let's do the y's. So 0, 4, 0, negative 4, 0. So our amplitude is 4 now on this one. X's are going to be 0, pi over 4, pi over 2, 3 pi over 4, and then just pi. So our period, it looks like, is pi. And now we're going to take these, we're going to add pi over 4 to all the x over 2's. Add pi over 4 there. And then if we have 4y, we're going to subtract 1 from each of those. Let's do those first. So we have negative 1, 3, negative 1 again, and then negative 5, and then negative 1. So center line is at negative 1 now, which makes sense because we're moved down 1. And so let's add pi over 4 to all these. So 0 plus pi over 4 is just pi over 4. So we're shifting by like just 45 degrees, or pi over 4. So think about the circle. Started with these values. Shifting them all just basically 1 unit. And this to here and this to here. Okay, so pi over 4 plus pi over 4 is pi over 2. Gets us to the top of the circle. Pi over 2 plus pi over 4 is 3 pi over 4. Do that with algebra 2, right? This is 2 pi over 4 plus 1 pi over 4 is 3. And then 3 pi over 4 plus 1 more is 4 pi over 4, which is pi. Pi is 4 pi over 4 plus 1 more is 5 pi over 4. And let's graph it. Now, one thing to be careful of, we are not graphing sine, right? We're graphing cosecant. So I'm going to have to graph sine with a dotted line, and then I'll graph in the secant with a solid line. So let's see if we can do that. So we start at pi over 4 this time, so that's a little to the right. And we are big. Let's see where I want to put that. I guess I want to put it on the top. So this is pi over 4. These get a little messy because there's a lot of lines going on, so I'm just going to try to be careful here. So then we have pi over 2 right here. We're going to be up to 3, so let's put it underneath. Then 3 pi over 4 right here. Back to negative 1, so I'll put it on the top. And then this one we're down at negative 5. Definitely put it on the top for pi. And then 5 pi over 4 is where we finish. Okay? Alright, so negative 1, let's say, is right here. So negative 5 then down here somewhere. Positive 3 up here somewhere. Trying to make it about even. Okay, so there's our center line. So we start at negative 1. Then we go up to 3. Then back to negative 1. Down to negative 5. Then back up to negative 1. I'm going to make a dotted line for the sine wave because we're not really graphing sine. We're graphing cosecant. There's our sine wave. So now we put in the asymptotes at the zeros. There's one there, one here, and one here. And I make the U's. Maybe I'll use a different color to actually graph the cosecant wave. So it's going to come down like this, and we'll have one like this over here. Okay, 1 period. That's all I ask for. So that is our graph for cosecant 2x minus pi over 2 minus 1. Cool. Now, you could erase the sine wave. I'm not going to do it because I have all these dots. It's going to be really hard to do on the screen. But the red is really the graph that we wanted to make. If you graph this in Desmos, that's exactly the graph that you'll see. It's just the red one. Nice. All right, I think I got one more. Number 12, I want to do a cotangent. So cotangent, I want to stay there. Okay, so cotangent, go back to a less offensive color. Remember, parent function looks like this. Asymptote at pi, 2 pi. Okay, it goes through at pi over 2 and 3 pi over 2. So that's because the circle you're using these cotangent lines. So you start off undefined, and then at 0 you're at pi over 2 you're at 0, and at 3 pi over 2 you're also at 0. At pi you're undefined as well. Okay, so this guy I'm going to clean the x first. So we have 2 cotangent 1/2 times x plus pi. That one's a pretty easy one to do without having to use an a, and then plus 2 at the end. So typical values for cotangent are kind of weird, but we can still do it. It'll still make sense. So we have y equals cotangent x. So our x value is still 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cotangent x, so it starts undefined. Nope. This works for tangent too. It's just, remember, they're opposite. It goes 0, undefined, 0, undefined, 0. So pi over 2 is 0. Then it's undefined again, 0, and undefined. Now this doesn't tell us a whole lot, right? Because the y values don't really paint a picture of where we're going. But as long as you know how the shape of the parent function works, it'll still tell us where things move. So let's take a look here. So if we do our scale change takes x, y, 2. It looks like 2x, and then it's going to be 2y. So we're going to do 2x and 2y here. So the y's are still the same. And this is kind of important. A scale change on tangent and cotangent is really not visible. And the reason for that is because, like sine and cosine, the amplitude changes, right? If you have a scale change of a sine wave, it's clear that it's changed. A scale change on cotangent, what's going to happen is, like, these points will move, but it's still going to have the same 0, and it's still going to have the same asymptote. So it's really hard to tell that something with cotangent or tangent has been scale changed. So it's not a big deal if you don't make it really clear that it's been changed. The big thing is the shift, how much it shifts left or right, and how much the period has changed. So 2x here, we'll have 0 still, and then we'll have pi, and then we'll have 2 pi. This is easy, right? 3 pi, 4 pi. Okay. So it looks like a period. Remember, the period of cotangent is usually pi, so the period is now 2 pi. We've made it wider, right? This 1/2 is a horizontal stretch by a factor of 2. So now we'll take our 2x's, and it looks like we're going to, I didn't write my translation. Translation is going to take this to x minus pi, and then the y's plus 2. Okay. All right, so we're going to subtract pi from all the x's, and all the y's that we already multiplied by 2, we're going to add 2 to them. So y's, undefined plus 2 is still undefined. 0 plus 2 is 2, undefined, 2, undefined. Okay. So these are all going to subtract pi. So we're subtracting half a circle from each one. So negative pi, 0, pi, 2 pi, and 3 pi. All right, well, let's graph it. Let's say negative pi is right here. Here's 0. Here's pi, 2 pi, 3 pi. So the undefineds are at pi, negative pi, excuse me, at pi, and at 3 pi. Okay, our center line is at 2. Okay, so at 0 we're at 2, at 2 pi we're at 2. So our waves are going to look something like this. And that's it. There's our graph. Okay, so we're shifted up. That's also not super obvious, but you have to make sure that you cross through the axis at those points. That's one of the important things. All right, that's all I've got for you here. So hopefully this was useful. You were able to get kind of started on the pink packet. The rest of them are on your own. The solutions are online, though, so if you need a little bit more help, you can check those out and see what they are. I also made one document with all table all the tables done, so you can check out how those work out. Love you guys. That's why I'm here. Have a great day.